All right. If you haven't had a chance to practice these over the short weekend there, I'm going to walk you through each of these before I assign some for you to do. There's already been one video posted on how to solve or simplify using polynomial long division. So let's take a look at the problems here. I'm going to start with problem number 1. Okay, so we've got x squared plus x minus 17, a polynomial. Remember, exponents all have to be to a nice whole number. In this case, a whole number of 2, and then a whole number of 1, and then it'd be like 17 times x to the 0 power, and 0 is a whole number. And we're dividing that by x minus 4. So let's set this up just like long division. And so our divisor here, x minus 4, we're going to divide into dividend x squared plus x minus 17. Now it's very important when you set these division problems up that it goes from decreasing order. So x to the first, then my constant term. We're inside, I have the x squared, then the x to the first power. I should have had a plus in there. Let me erase just a little bit. Rid of him. And how about plus x and then minus 17. Again, going in order of degrees. So here we go. The first thing you want to ask yourself is, what do I have to take this x times to get an x squared? And the only answer to that would be an x. So I put an x right above that x squared, and then you're going to distribute. And the result, x times x, is x squared, lining him up underneath the x squared. And this is an x times a negative 4. So that's a negative 4x. We draw a line underneath those two. Put parentheses around it because we have to subtract that entire line, just like we would do in long division. And so what we end up here with is x squared minus x squared, which is 0x squareds. They've canceled out. And this is x, but it's going to be minus negative 4. So it actually becomes x plus 4x here, giving us a total of 5x. Okay, so this negative got distributed, causing x squared minus x squared, and then x squared, the negative got distributed there, making this a plus. So it ended up with a 1 plus 4. The 1 in front of that x, giving us 5x. And then we just have to slide down the next term, minus 17. Now we just repeat ourselves. We ask, all right, what do I have to take x times to get a 5x? The answer would be 5. So I put plus 5 up here, and then I distribute that. And that will be 5 times x, which is 5x, perfect match, which is what I wanted, and 5 times negative 4, which is negative 20. Strike a line, draw parentheses to subtract that line. And so now I've got my 5x, take away 5x, so my x's are gone. This is going to be negative 17 plus 20 right here, because remember when we distribute that negative, that's the negative 5x, but here it gives us plus 20. So negative 17 plus 20 is 3. I can't take x times anything to get a 3, so that is my remainder. So this would be a remainder of 3. Now the way that we generally write this is we would write that this is equal to x plus 5 plus our remainder over our divisor, x minus 4. Okay, so that is a long division problem. And that remainder, that 3, is going to be important to us later on. Let me walk you through another one so you can see it, and everybody, you can see these just take practice. This is just doing long division. I showed you a long division in the first video. Hopefully doing more practice problems with the long polynomial division will help you out. So here is problem number 2. Here comes the setup. I've got x minus 5, and I want to divide that into, this is number 2 again, a 3x squared minus 14x minus 5. The process is, again, relatively simple. We just have to ask ourselves, x times what would give me 3x squareds? Okay, this is a 1, so 1 times 3, so it's going to have to be a 3, and this is an x. To get an x squared, I'm going to have an x, so it will be 3x. And then we distribute that 3x to our divisor, giving us 3x squared, and 3 times negative 5 is negative 15x. Strike a line and subtract that row. And you can distribute in your head or distribute physically and go, okay, so that's now negative, and this one will become positive as you add. And so you can see the first, when I do the 3x squared, it'll become minus 3x squared, so they add up to 0. This is negative 14x plus 15, so that adds up to 1x. So we'll just put 1x like that. Just put the x, and we bring down the next term, negative 5. And then we go, well, what do I have to take x times to get an x? The answer is 1. 1 times x is x, so I put a 1 up here. I distribute that 1. Like so, giving me 1 times x and 1 times negative 5. Strike a line, and I subtract. This is x minus x, which is 0, and negative 5, and this will become plus 5. Again, remember this negative sign goes there, and it'll make that negative a positive. So this all adds up to 0. So in this case, there is no remainder, and it tells me that x plus 5 divided into 3x squared minus 14x minus 5 perfectly as 3x plus 1. So the answer to number 3 here would just be 3x plus 1. Now this brings us to the point of why we're doing this. Eventually, to solve these polynomials, we're going to have to get them into factored form. And if you recall, once we have them in factored form, we can use this thing called the zero product property. And so essentially what we have just done is we have factored 3x squared minus 14x minus 15 into its factors. It's divisible by x minus 5 and 3x plus 1. And so if we were trying to solve this with the zero product property, we could then find our zeros. So we really like it when they come out even, like that second one did. All right, example 3. Example 3 is a little bit tougher. So here we go. Give ourselves a little space. Here's our setup. You got to divide x squared minus 1. Now, when I write that, there's x squared. If I just put minus 1 next to it, I'm missing the x term, so we always want to put spacers in there. So I rewrite it as x squared, 0x's minus 1, and you'll see why that's important as we go through. And we're going to divide that into x cubed, or plus x squared, plus x, they're all in descending order, plus 2. Well, this looks like a bigger problem. The longer the polynomial you are dividing by, the actual quicker they go many times. So all we have to do here is go, hey, x squared times what to give me x cubed? Well, I just need an x. So I'll put an x up here. And I distribute that to each one of these. So that's an x cubed. That's 0x squareds. And this would be negative 1x, or just negative x. We draw a line, and then we subtract. And so we get x cubed minus x cubed, well that's 0. X squared minus 0 x squared, so that just stays as x squared. We've got x, and it's going to be distributing, so it's going to be an x plus x. So it's going to be 2x. Right there again, if you'd like to, you can show that negative sign going to each thing here. And here it becomes a plus as it crosses over. So 1x plus 1x is 2x, and then we bring down the 2. We ask the same question. What can I multiply x times to get x squared? The answer is 1. So I go, all right, multiply by 1, and I distribute that 1. I go 1 times x squared, 1 times 0x's, and 1 times negative 1. Strike a line and subtract. X squared minus x squared, 0x squareds, 2x squareds minus 0, still 2x squared, and this would be 2 plus 1, so plus 3. We can't take x squared into 2x, and therefore this is our remainder. So our final answer would be this division problem. X squared minus x, or x squared minus 1 goes into x cubed plus x squared plus x plus 2 goes in there, x plus 1 times plus our remainder 2x plus 3 over our divisor x squared minus 1. And we are done. So that 2x plus 3 would be what you would usually call your remainder, like that. And so that's all we're doing is practicing these long division problems today. I know some of you practiced them. On Friday, I'll give you a new set of just 3 problems, just because they do take a while, and then we can discuss any errors, and we'll be able to show you a shortcut at some point. Alright, so take a look at this video and come to class with questions, and that is it for today.